Okay, have you tried question 5b? 5
Yes, teacher.
can. Have you tried? Can do or not?
Can.
Can. Other girls? 5b, yeah? 5b. Okay, so if you have done mine, you just follow, see what you have done is correct or not. 5b is 3x. 3x over 4x plus 6. 6. Okay, right. Delete. Right, okay. Then dy over dx. Dy over dx. Okay, right. Equals to. So you differentiate the top. You left with 3. Okay, differentiate the top. Bottom you keep 4x minus, 4x plus 6. 4x plus 6. Okay, right. Then minus the sign at the center is minus. Then just now you differentiate the top, now differentiate the bottom. Differentiate 4x plus 6, you get 4. Keep the top is 3x. Oh, top is 3x. Okay, right. Then the bottom, 4x plus 6 raised to the power of, not this, raised to the power of 2. So whatever that is at the bottom, you have to raise to the power of 2. You have to raise to the power of 2. So this is the differentiation process is over. You have to simplify. Okay. Okay. Now we have to simplify. Okay. How to simplify? Hmm. Hmm. So simplify, you have to multiply it. 3 multiplied with 4x is 12x. 3 multiplied with 6 is 18. 18, right? Then minus 12x. Oh, 12x again. So it actually will cancel off. It will actually cancel off. Then the bottom still the same. The bottom is still the same. Bottom is still the same. Then 12x and 12x will cancel away. You have 18. The top you are left with 18. And the bottom still the same. Okay, so this is how you do 5b. Then you may ask, can I do it this way? Composite function? Answer is cannot. Why cannot do it this way? Because the function at the top has x. So once there is an x there, then you cannot use the composite function alone. Right? So you have to use this way. Okay, any question? For those of you who have tried 5b, then you have something different from me, then you ask. The other girls with you have tried 5b, ask. Okay, if no question, then I will go on to the more difficult examples. 5b can or not?
Can, teacher.
Can. Okay, can. Can, then we go back to more difficult examples. So
Teacher,
yes,
you're not sharing the screen.
not sharing the screen.
Yeah.
Okay, okay. Wait, okay, okay, now. This is a more difficult example. We have this one. Find the derived function for y equals to x plus 1 raised to the power 3 divided by 2x plus 1. Now, why is this more difficult? Because the function at the top is a composite function, right? So earlier on, example number 1, example number 2, we don't have composite function. So now we are combining the composite function with the uh, quotient rule. We are combining composite function with quotient rule. Okay, so I copy down the question again. The function at the top I color pink color. Function at the bottom I put down orange color. Okay, now you have to differentiate the top, then keep the bottom, right? Now, while you are differentiating the top like this, you have to bear in mind that the top is a composite function. So you have to differentiate it using the chain rule. Using the chain rule. So these 3 bring to the bottom. 3 less by 1 become 2. Then differentiate inside the bracket. You have 1. Now some students, they say, hey, the 1, no need to write. But of course, in this case, whether you write the 1 or you don't write the 1, the value will come out to be the same. But make it a habit to write a 1 there. Why? Because if you don't have the habit of writing the second bracket, when it is no longer 1, when this is 2x or when this is x squared, then everything will be wrong. So make sure that even though it is 1, you write down 1, then put a bracket there to keep it the habit, to make it a habit, so that when you encounter something else, you still do it correctly. So this is how you differentiate the composite function. Then the function at the bottom, you keep. Second step, differentiate the bottom, then keep the top. Differentiate the bottom, you get 2, right? Come from here. This orange color come from this function. Then the function at the top, don't do anything. You just keep. Okay. Then the function at the bottom, the whole thing raised to the power of 2. Okay. Right. So far, can follow or not how to differentiate using the quotient rule?
Yes, teacher.
Okay, so can, so we continue. Now, this composite function usually raised to the power of 3 and so on. So there is always a common factor that you need to factorize when you look at this composite function. So want to factorize them, you look at the common factor x plus 1 square. Here x plus 1 cube. So you take out x plus 1 square. So don't try to do 2 factorization at one time. So Li Yin, don't take the 3 then put outside. Then take the x plus 1 also put outside at the same time. No need, right? So do one at a time. But of course, if you have done many problems, then you can do 2 factorization at one time. But for the beginning, you just take out one factor, x plus 1 square. So when you take out x plus 1 square, you are left with 3, 1, and the orange bracket. So 3, 1, orange bracket. Okay. Right. Now, the second one, when you take out the term behind here, when you take out x plus 1 square, you are left with 1, x plus 1. Right? Then the 2 is also still there. You have not factorized any other numbers or x, right? So still there. So the next step, this factor, you just copy down. Whatever inside the bracket, you expand and simplify. 3 times 2, 6. 3 times 1, 3. 2 times 2x, negative 2x. Negative 2 times 1, negative 2. So you just open up all the bracket and simplify. So the rest you just copy down the same. Right? This one copy down the same. 6 minus 2, 4x. 3 minus 2 become 1. So this is the answer. Right? X square, x plus 1 square, 4x plus 1 over 2x plus 1 whole thing square. So this is the answer. Any question with the differentiation or the simplification? Now simplification, do it step by step. For the beginning, you just do it step by step. Take out one factor at a time. Don't try to take out two. Now, after you have done many problems, then you take out two. Any questions?
No, teacher.
No. Then we look at the last example. Ayo. Now this question involves square root, and not only square root, but the square root is at the bottom. Square root is at the bottom. So very difficult. Never mind. Let's try. Let's try. Okay. So now fx is x over square root of 2x plus 1. Now if you look at the square root, the index is not a number or a fraction, so quite difficult for you to differentiate. So the square root you have to change to power of half. So the function at the top is x, the function at the bottom is 2x plus 1 raised to the power of half. Okay, so now we are going to perform the quotient rule. Differentiate the top, keep the bottom. Okay, differentiate the top, x become 1. The bottom is this thing, 2x plus 1 to the power half. You just copy down 2x plus 1 to the power half. Now, this is differentiation process. This is not simplification process. So you don't try to see that, oh, okay, coming. Okay, now you look at the example 4. I'll come back in 5 minutes time. Okay, I'm back. So are you with me? I'm back already. One, two.
Yes, teacher.
Okay, right. So what I want to tell you is that this 2x plus 1 is actually, you just keep whatever that is at the bottom here. Now, the process is part of differentiation. So you don't try to say, oh, this term at the bottom, I bring to the top, I must put a negative half there. No. Okay or not? Don't, whatever you see just now here, 3x minus 1. 3x minus 1, I just keep it. Did I say that, oh, this 3x minus 1, I go to the top, I must put a negative 1 there? No, it is part of the differentiation process. So you don't have to put negative 1 here. Right? Or for all the other 3 problems here, we don't do like that. Right? Okay, so right. So you just differentiate the top 1. Copy down the bottom here, keep the bottom, copy down. Right, so this is it. Minus, now you have to differentiate the bottom here. Now the bottom here is to the power of half, and it is a composite function already. So you bring down the half, 2x plus 1, half minus 1. You see, I didn't put negative half minus 1, it's half minus 1. So whatever is at the bottom there, I just copy down. Half minus 1. Okay, then differentiate inside the bracket. Differentiate 2x plus 1, 2. Then the function at the top, you just keep x. Okay, then divide by the function at the bottom there, square root of 2x plus 1, square. Okay, the square comes in when you differentiate. Right? So this is the original one, 2x plus 1 to the power half, or you can write as 2x plus 1 to the power of a square root of 2x plus 1. Then whatever is at the bottom there, you square it. Any question?
No, teacher.
No. No means you understand, right? Okay. Then I try to simplify. Now this 1 multiply with this thing is the same. So I just write down the same thing. But instead of writing down the same thing, I just put it divide by 1, right? Because a is actually a to the power a over 1, right? So just write it like this. Then this one, the 2 and 2 will cancel away. Then I'm left with x. Half minus 1, negative half. Okay, so negative half means the x is at the top, this is at the bottom here. X over 2x plus 1 to the power of half. Then the bottom is okay. When you square and the square root meet, no more square root. It's just that no more square, no more square root. It is just 1, right? Just 1. So far, okay or not? Here, until here. Until here.
Yes, teacher.
Yes. So I'm
Understand.
going to the numerator, I'm going to add them up according to this way. A over B plus C over D equal to AD plus BC over BD. So I'm going to add up these two terms according to this way. So multiply this with this. I just add the indices and it become 1. 1 multiplied with x minus x. And the numerator, the denominator is half, square root. Okay. So 2x minus x become x. The 1 become 1. And this square root, I bring it to the bottom here. Bring it to the bottom. So this is the answer. Question. Any question? Other girls?
No, teacher.
Jia Yan, Chen Tong. No, no question. No question. No question, then you look at the question here. Uh, this one. C is so still very simple. C, D, E. Oh, Chen Tong also can understand, so no question. So you look at question number 5 here. Question number 5. Anyone looks very difficult and you want me to show you. Is this difficult? H.
Yeah, teacher. Try first.
Ha. H difficult. You want me to show? Uh,
Try first. Try.
Try first. Okay, you want to try first. Then you try. Oh, H is very difficult. As you try, I write on the screen here. Okay? As you try, I write on the screen. Okay, are you ready? Are you ready?
Yes. Yeah.
Okay. Now, this function here, 4x plus 1 over 3x squared minus 7, the whole thing square root. The whole thing square root means what? No? It means that this thing over this thing to the power half. Is that correct? Is that correct? Okay. Now, if you write it this way, it is a composite function, a single composite function. So when you want to differentiate this thing, you have to differentiate it like a composite function. The half you bring down, then the half minus 1. Then after that, you have to differentiate inside. The problem is when you differentiate inside, the inside is actually a quotient of two functions. So you have to differentiate it using the quotient rule. And it becomes like this. Differentiate the top, then keep the bottom, minus, differentiate the bottom, then keep the top here, then divide by this whole thing square. Okay, so it's complicated like this. And you have problem going to simplify also, right? Now, if you don't want to do it this way, then you try to break up because this thing is holding to the power half. Then you can say the top function raised to the power half. Then the bottom function also raised to the power half. Now in this way, when you try to differentiate the function, you only use quotient rule. That means you differentiate the top, keep the bottom, differentiate the bottom, keep the top. But if you do like that, each of these is a composite function. That means when you want to differentiate the top part, the pink color here, you have to use composite function. Then you keep this. Then when you want to differentiate the orange part, it's a composite function. Then you have to differentiate, then you keep the pink color. Right? So either way you encounter composite function. So you prefer to do it this way or you prefer to do this way, right? Or I let you try this, right? If we cannot, then I explain to you the next lesson, right? So we stop here. Then you finish this question number 5 and number 6. 5 and 6 also this one, okay? Formative exercise 2.2, right? Formative exercise 2.2 and exercise 2.5, number 5 and number 6. So when you start doing, you can start asking questions. Every day also you can post your question on the Telegram, and when I see your question, then I will answer them. If you still cannot understand, then we will discuss it the next lesson, because from now until next lesson you have 1 week. Okay, right. So we're going to stop here because only 3 minutes left. I cannot show all this in 3 minutes. So we're going to stop here, right? I'm going to end now.